types of intramolecular bonds are covalent, ionic, and metallic. Intermolecular forces include ionic compounds, ion-dipole bonds, and van der Waals forces, which are exhibited by covalent compounds. Van der Waals forces include dispersion, which is weak, dipole-dipole, which is stronger, and hydrogen bonding, which is even stronger. Ionic compounds have electrostatic intermolecular forces that result in strong bonds with other ionic species. For example, one sodium chloride is attracted to another sodium chloride to form a crystal of salt. There are also ion-dipole bonds, which are between ionic species and covalent molecules, specifically polar covalent molecules. These bonds can be strong. These forces of attraction can operate, say, in a solution of sodium chloride in water. The solute, sodium chloride, dissolves, dissociating into ions, sodium cations and chloride anions. The solvent molecules, water, surround the ions. Covalent compounds have van der Waals intermolecular forces, which vary in strength. The weakest of these van der Waals forces are London dispersion forces. These are attractive forces that occur between temporary dipoles and induced dipoles in atoms or molecules. The larger the molecule, the stronger these dispersion forces are. Van der Waals interactions exist because as electrons buzz around the nucleus, the distribution of charge changes with time. At any given moment, this distribution isn't perfectly symmetric. This transient asymmetry can induce complementary asymmetry in the charge distribution of nearby atoms and attract those atoms. This attraction is inversely correlated with how far apart the atoms are up until the point where outer electron clouds overlap, creating strong repulsive forces. This is termed the van der Waals contact distance. In addition, there is weak attraction between the nuclei of one molecule and the electrons of another. The more electrons are present in a molecule, the stronger the van der Waals forces. Dipole-dipole interactions are stronger. These are forces of attraction between polar molecules. For example, HCl has a dipole. The chlorine atom is much more electronegative, and so the electrons spend more time near it. When two HCl molecules are nearby, the negative end of one is attracted to the positive end of another. The strongest van der Waals interactions are hydrogen bonds. This special kind of dipole-dipole interaction forms between the hydrogen in a polar bond like OH or NH and the electronegative, electron-greedy atoms O, N, or F, which is the most electronegative atom. For example, water molecules form hydrogen bonds with other molecules, giving water many of its life-sustaining properties. Note that water is a polar molecule, and it is known as the universal solvent because many covalent and ionic compounds can be dissolved in it. Hydrogen bonds